All right, video number 2 of the how to wire Schneider Modicon M221 PLCs. Today we're going to go and take a look at the whole concept of syncing and sourcing. What we're going to start with though is we're going to start with a very bold statement right over here. And this statement is, if you have always struggled with this and you're in doubt when you are using a grounded negative DC system, go with the safest, which would be inputs as syncing, outputs as sourcing. And what you'll see over here is my handy little memory trick to remember which is going to be which. IN for input is also available in the word syncing. OU for output is also going to be in the word sourcing. And this would also be known as using your IEC positive logic. Later on in the video, we're going to explain exactly why this is the safest. So if you disagree with this, hang on and you can argue with me later. If you don't know why this is the case, hang on and you're going to find out shortly. All right, the concept of sourcing and the concept of syncing are all tied down to what we are using as a direct tie. Sourcing is going to be direct connection of the positive to the reference or the common of my terminal, whether that's going to be for the output terminal or the input terminal. Syncing is going to be direct connection of the negative to the reference or the common type of terminal. And what I do want to point out as well is just this little statement over here at the bottom. IEC, positive logic and negative logic are related to these concepts, but they are completely different. And I promise I will, deal with them at the end of the video, explaining which is going to go and be which. Let's jump into a couple of data sheets over here. We've got a data sheet for a relay type of Modicon over there, identified with the R over there. They show us that we can go and use syncing wiring diagram. Remember that syncing was going to be attaching the negative. So here's my negative supply, and that's what they're highlighting. The negative is attached to the common. Alternatively, with this one, I can go and attach the positive to the common. In that case, I would go and have a sourcing type of wiring diagram. We're going to go through these in depth later on. So we're not going to go and spend a lot of time with it, other than that we see for the relay type, we can use either syncing or sourcing. When it comes to the transistor type, they give us a very similar type of idea. We can either go and have a syncing type. They do give us an A. See that little A over there? They say A is sync type of wiring or positive logic. And what they're showing is that we've got a external supply. We've got the negative attached to the common. And then that we are going to go and feed the positive out through a fuse to all the rest of our inputs. Alternatively, on this same one over here, by the way, it's a transistor type identified with a T, we can also work with a source type of wiring. And that would be where I'm going to go and take the positive. And you see they take the positive through a fuse into the common inside over here. So once again, either type is going to be available. When it comes to outputs, I'm able to go and do either as well. They're showing us on this very first one here that we can go and do a syncing type of logic that's going to be available over here. That's B. They're showing us with all of these over here, where they say a syncing type would be, once again, a negative attached to the common is going to be my syncing type for my outputs. And we can also, if we're using relays, go with a sourcing type, which is where we're going to go and have a positive that's going to be attached to my commons. Once again, we are going to deal with all of these as individual small fast videos later on. We're just sorting out that we can go and use pretty much any of these for any of these until we get to the transistor output types. So if I've got a transistor output type, I'm going to go and have one of two designations. T, which is going to be my most common transistor type, which is going to go and provide a type of, and if you take a look at this, you should be able to identify it. We see that we are going to go and have a source type of wiring that is going to go and be fed out of this because we've got the V, or the power supply, attached into the V over here. We'll deal with this reference. That's going to be in there later on as well. So transistor outputs on a T will be source type. And the very last type that we have is we've got one other type. It's a lesser used one. It's got the U designation over here. And it is going to go and be a sync type. And you'll note that the negative of this power supply is now the one attached to my common terminal. The common terminal in this one being the V negative. And I'll explain that one once again in a later video. So syncing, anytime that we have got the negative attached to the common terminal. Sourcing, anytime that we've got the positive attached. Let's take a look at how that actually looks inside of a PLC. What we have over here is a Modicon that does not exist. Let me be very, very clear. This Modicon that is drawn inside of here is something that I have made up over here. And we're just going to take a look at all the different terminals that are inside of there. The top part over here, the inputs, very much the same as what they would be in there. The bottom part over here, I've got some syncing inputs, I've got some sourcing inputs, I have got some relay type of inputs in the bottom. So this is not one that they make. I've just combined them all onto the same one for the sake of the visual to explain syncing and sourcing. And then later on, you're going to select the correct model of Modicon that you have. Use that, follow the correct video, and I'll show you the correct connections inside of it. This is simply explanatory. On the PLC itself, you'll note that I've grayed out my PLC in the background over here and that I've applied this purple wiring over top. And this purple wiring just shows the internal pathways for power to circulate through here. This is my common terminal on my input side over here. And you'll see that that common terminal is going to go and, if I zoom back out here a little bit, go over to both of these groups of internal LEDs. What those internal LEDs are doing for us is they're providing optical isolation. When I provide power between this common and this over here, it's going to send current through one of these two, whichever one's going to be forward biased, or perhaps both if it's going to be AC. And that is going to go and provide a flash of light. Usually it's going to be infrared light packaged inside of a little optical isolator, but that optical isolation, in other words, transferring the data, the higher the low, through the light to my logic processor is what protects the guts, the brains of my PLC inside of here. On my output, I'm going to go and have the same type of thing. I'm going to have photo transistors that from my logic processor here are going to receive a light signal through a electrically insulating glass barrier that is then going to go and trigger the transistor that we are going to go and have. If you take a look at this one's going to have a PNP type of transistor. This one is going to have a NPN type of transistor. Or alternatively, I can close a relay, and that would be done through relay isolation, which is going to be using the magnetic fields. Once again, provided from inside of here, we'll provide a magnetic, a coil inside of here that will go and cause the relay to go and close in. We'll deal with those all in a minute. We're going to just follow through on my proper power path, same components as we saw in the previous video. We have got a breaker here for my AC coming in. We've got a DC supply. We have got a DIN rail bonding type of terminal block over there. We've got a fuse holder inside of here, the kind that lights up once this thing goes in, faults out. Down here on the very bottom, we do have a small load. We've just put a solenoid on here for now. And up top over here, we have put a push button so that we have got some way to go and trigger these inputs. All right, let's go and deal with a input first, how we wire in an actual input. So I'm not going to show all of the power path. What I will show you though is some of the more critical part. The more critical part is going to be me running down through here. I've got my positive. I'm bringing it into the bottom here just so that it makes a cleaner diagram over here. We can bring a positive in here, and then when I take that positive, I'm going to bring that positive into one of my inputs that I have over here. I'm going to take it over here. Oh, why don't I just clean that up and make that a little bit clearer which terminal it's going to. If we take a look at that, and if we try to track through the power path right now, what we'll see is that the power can get into the PLC, it can travel through one of these LEDs, the forward biased one, but then it stops over there. It has got no return path all the way through. So it's not actually going to go and light up one of those little optical isolation LEDs on the inside. What we have to do is we have to go and provide a reference back. So what we're going to do right now is we're going to go and provide that reference back like this all the way to my negative. Remember, whenever we take a negative to the common, it is going to be a sink that we are dealing with. Negative to the common gives us a sink, and we're going to follow that power path through one more time. If we take a look, we can see that we could bring power into my fuse holder here. My fuse holder, then we can take it through that push button when we press it. When we travel down and through there, we will travel through this LED, and we have got a complete pathway all the way back to my DC power supply, which means that when this push button is pressed, we will get a little bit of infrared light inside of the optical package inside there, which is going to send a signal to my logic processor telling us that we have got a high input. This is going to be a syncing type of input that we are going to go and have. Let's try this again, and we're going to go and try this now with a sourcing type of input. For sourcing, we're going to go and have to bring the positive to the common, and then we will have a source type. My apologies. Spelling is not always my strong suit. All right, we're going to do the same thing. We are going to go and take a look at what we have inside of here. We're going to go and run a positive. And this time, remember, we're doing a sourcing, so we're going to run the positive to the common, which would mean that we have now got a power path that is going through, up, into here. We've got constant power that is going to be brought up through each of these, waiting on their terminals that we have over there. We'll erase that power path for now. We're going to go in and finish that off with this over here. My push button to complete that power path would have to go through like that. Let's follow this power path through. We can see that we have got power carried in on the plus 24. Carried in, it is going to travel through this time. This LED inside of that package, back-to-back LEDs, travel up through. We're able to make it through that push button when it's pressed and carry it all the way back to the source over here. This is going to be referred to as a sourcing type of input that we are going to have. Whether we look at this one or the previous one, the really important thing to note is that both of them, or either of them, are going to go and light up one or both of the little LEDs that we are going to go and have inside of there. Infrared LEDs that are going to give us, once again, that logic high that my processor can then go and read. You'll note as well, because it is for each one of these inputs, and this is a package inside of there, tiny microelectronics that is going to be inside of there. It can go and handle AC as well, because AC is simply going to be current going back and forth. Each of these we're going to alternate which one is lighting, so we're going to be able to go and have that signal carried in on some types. Now, this type that we have over here does not handle an AC input, but you'll find it on other types of PLCs where they can handle the AC input because of that. Okay, let's now talk about the danger with a sourcing type of input. And the danger is caused by what is sometimes termed as being a safety. And that safety is, and we're going to take this thing all the way back to this point over here, that safety is that you will find a lot of DC power supplies are going to go and have the negative grounded. These can be requirements of codes based upon the VA that you have, the type of system that you have, or it could just be best practice that people like to go and have a grounded one, or sometimes this grounding even happens internally. It's an internally grounded negative that's going to be inside of a DC supply. We're going to place this on here because it's common to go and find. We're going to track through our issues now. So our issue would be that we've got our positive. We'll run that positive down into here. We're going to run that positive through into here. And then we're going to go and run out our field wiring. I'm going to change colors here. I'm going to go make this one here a fuchsia type of color that we're going to have over to that one. And then we are going to go and have from here another line that is going to go back over here. Same wiring path as we had before. The only difference is this. Once again, following through, we see that we have got that path, complete path for current that's going to allow this thing to light up when that push button is pressed. The danger with this is if there would be an accidental crushing of your cable or an accidental grounding of your cable that would happen right over here, we would now have an alternative path from ground through the CAN back to ground over here. And if you follow this through now, we'll do that. We see that we have got power, comes through our fuse holder, comes into here, comes in through here, and then comes up, and here we hit that ground, and we are able to track a path all the way back in from here to my negative. In other words, a ground fault on the cable can cause operation of this type. So a sourcing type of input is going to go and have some dangers that are going to be inherent anytime we've got a grounded DC supply. If this DC supply was not grounded, at that point there would be no danger because there's no complete path for the current flow, right? If we follow this through over here, we see that there's nothing. It can't travel, it can't get back to the supply anyway. But if the supply were to be grounded the way that we commonly see these done, then we're going to go and have issues. Because in a lot of industrial applications, we're going to have multiple DC supplies inside of there. You might not have grounded your DC supply, but if it shares a common with other DC supplies, one of which is grounded, there will be a path back through. I am very, very, very leery of using this type, a sourcing type of input for that fact. All right, we're going to erase these now. We're going to move on to our outputs. We will deal with a sourcing output. I guess I could have left that up there. Sourcing is going to be where my common is going to be attached to the positive. That would be termed as being sourcing. We'll do the same thing again. We've got our DC power supply over here. We're going to go and feed our positive out of this one. We're going to feed it into a fuse holder the way that we're supposed to go and do that. And then we are going to go and feed that to a component. Now, this is my sourcing block, and what I want you to be very, very clear about right now is that this block that we have in here is the only sourcing. This one is unrelated. I drew it in so we didn't have to change drawing. Same with this one over here. I drew it in so we didn't have to change drawing. We're only looking at these three sections that we have over here. So on my sourcing type of card over there, I feed my positive into the card, and then my positive comes out of the card, travels through the card, and then it goes, we'll use this fuchsia color, to my load. We've got this little solenoid over here, and obviously this solenoid is going to need to have some sort of a return path back. We'll take that one up and around like that. Over there, now we have got a more or less complete circuit. We'll follow that through here, positive through my fuse holder, through into my common terminal. It's going to be labeled as a V+. We're going to see that on the individual ones later on, which then travels through this transistor that is triggered from inside of the PLC, passing the current out, going through, energizing my solenoid over there, and then coming all the way back to my negative supply. We have got a complete path for current off of this one. Do note as well that if there was a ground fault off of this cable, it wouldn't make any difference because at very worst, it would be able to go and track back to this supply if it were grounded. If we had a ground fault on this cable right over here, what it's going to do if we got a grounded supply is it would trip out this breaker, and it's not going to go and operate any loads outside of the field. It's a safe type of connection that we would be dealing with. Let's erase it. Let's go and check out our other type of connection that we have. Our other type of connection is going to be our sinking. Remember that sinking is where the negative is attached to the common, and therefore we call this thing sinking. This is going to be one where we have got, and I'll draw this one through over here. We've got our negative that is going to be carried through up to a terminal. That's going to be on our PLC. We'll zoom in on this one over here. We see that it's attached here to the V negative. We'll deal with the individual connections later on, but this is going to be the common for these types, and then it's going to come out on a Q. It's labeled QU here because the sinking type of Modicon has got the U designation. By the way, the sourcing type has got the T designation. That's why it's QT, and the relay has got the R. That's why that's QR over there. But coming back to this one, we got that U over there. So we see it comes in onto the common terminal, which is this V negative, and then carries all the rest of the way through. From there, we would then be able to go and carry this thing out. We'll switch colors over here, and we'll go to a dark blue. We would carry that out over there to my negative terminal over here. And then this over here is going to go and carry the rest of the way back through. We've got a complete path for current flow. Once again, if we take a look from the positive through the fuse holder protection that we're going to go and have through my load itself, through the actual PLC, through that transistor that gets fired by the internal logic circuitry, all the way back to my supply over here. Fantastic. This is exactly what we are looking for off of these ones. This one, however, does have some dangers. Once again, the danger is always going to go and be prevalent whenever we have got a grounded negative on our DC. Let's follow that through, and what we're going to do is we're going to go and accidentally ground this cable over here. If this cable were to get crushed and the negative were to get crushed up against the shield around the outside, if the shield is grounded down or crushed inside of a pipe or cut, whatever it's going to be, if we end up with a fault on the negative inside of here, what we'll get is continuous unwanted operation of our load. Follow this through. We've got a positive tracking through all the way into here, going through our solenoid, and then we hit this. As soon as we hit that ground fault, we are then going to be able to go and track back through the ground path itself. So back through, the boxes, the enclosures, and things like that. We could track back through all the rest of my bonding system to my supply over here. And what you see is that we have got unwanted operation of this solenoid, even though the PLC itself over here is not calling for it. this is going to be a danger for us. So syncing on my outputs is generally termed as being really, really bad. Remember that very first slide that we took a look at where we had this right over here? When in doubt with which to use with a grounded negative DC, go with the safest. Input should be syncing, output should be sourcing off of these ones, or what is known as IEC positive logic. Let's talk about IEC positive logic. IEC positive logic is neither syncing nor sourcing. What you will note is that it does use both syncing and it does use sourcing. But what it is it is using the positive to activate something. We term that as being my IEC positive logic. So if I bring my positive to an input to trigger it, we would need to have a syncing input. We are using positive logic. If I bring my positive out from my PLC to a load to operate it, we would need a sourcing output. We would be using IEC positive logic. Negative logic is where I'm using the negative to activate something. So bringing a negative to an input to trigger it, I would need to have a sourcing type of input for that. That would be called IEC negative logic. Or bringing the negative out to a load to operate it, I would need to have a syncing output for that, would be both termed as being IEC negative logic. Note, and this is the super important part of this, is that if the negative is grounded, your DC supply is grounded, a ground fault can activate a IEC negative logic. Okay, North American wiring, we don't use a lot of grounded positive DC. Almost every time that we see DC, it's either going to be a floating system or it is going to be a grounded negative for it. So as much as possible, I suggest for those of you, if you're unsure what the system is, or if you're taking the system and you're bringing it to an existing installation where you might not be able to find every DC supply that's out there, I suggest not using the negative logic and instead make sure that you are using positive logic. Syncing inputs, sourcing outputs. This will be your safest 99% of the time from my personal experience. All right, that covers through. This should probably be our longest video in the entire series. From here on out, we're going to take a look at individual bite-sized pieces of the individual Modicons themselves.